Hey everyone, welcome back to the channel. Today we are diving into a super useful topic for building scalable and maintainable APIs in the clean architecture. We will implement the new pagination logic, and we will also add some base filtering and order by functionality in this C# template app. This will serve as the foundation for all GET requests in our clean architecture application. So by the end of this video, you will have a reusable and a clean solution that you can apply to any project. So if you like the video, please leave a like and subscribe. And let's get started. We will create a base structure for handling GET requests that supports pagination to limit the number of records returned and allow clients to request specific pages, filtering to enable clients to filter results based on specific criteria, and ordering to sort results by one or more columns. This will all be implemented in a clean architecture template, ensuring separation of concerns and maintainability. So let's start by building new branch. So in Rider, it will be very easy to do this. You just go here. Let's say filters, pagination, like this, and it's created. Okay. If you remember correctly, we implemented our logic as a repository pattern. So we need to do the same thing here. We have some interface here, iRepository. As you remember, we use this get all async to return all of our records in the database. So we are going to change this and make here some logic that will be base for everything. So let's for now add a new function here, public task let's say for now this get all with filters is like that. We will see what parameters we need here and what we will return, but for now let's stay like this. As you can see, we need to implement it here in our repository. Okay, like this. So we have implemented it. Now we need to handle the logic. So what do we need? How do we paste the data? So we need to pass here some data like our request filters and pass that to some function that will handle all of this. All of our filtering, all of our sorting, not sorting, but order by, all of our pagination and things like that. We will do that by creating some class like generate filters, generate pagination. So this filter method will probably be a query extension because we will work on our query. So, but we will create folder, maybe filter, something like that. So we know what do we do there. And we will create new class, base filter or apply filter. Will be better. Okay. Now what do we need? We need to create some static method like this. So we will pass iQueryable type T. Okay, apply filter, that's okay. It will be query extension. Query. Like that. And in here we will not send that. We'll send some different method. But okay. Let's make this static and let's for now return query. We will give the different name to the file. We will say something like base filter, like that. In here we need to pass the filter. So what do we pass here? We need to pass our request query params. But what params? How we want to pass? I want to be able like to make my request like this API, like products or something. And in here, what do we send? So we'll send like skip and take for pagination, like skip one to skip one page and take, I don't know, 0. We will maybe specify some default values if like zeros are sent or -1 is sent. If -1 is sent, okay. And we will here then add our filters, like if product, we will have something like equal, less than, greater than, like product equal to some name. And now we need to parse this query param. So we need some parser. So we will, in the Web API project, create a new directory called common. And in here, we need to create our query parser. Okay. So this class will have one method that will parse our data. Public static, what do we return? Like this. For now. So we need a type to return. So what do we return? We need to make our custom query parameters that will populate. Okay, so where do we add them? We should make some DTO, possible data transfer object, and in here also some other type, 2 DTOs, you called filter criteria. Okay. In here, what do we need? Let's first filter criteria. Okay. So we'll have all will be string values. First will be property. That will be the first things. As you can see, like this products. That's the first thing. Okay, property. Then we have the operator, less than, equal, things like that. Okay, and we have the value. Like that. So that's for filter criteria. Now we need the whole query parameters. Okay. So in here, as you remember, we have public skip, which will be default 0. Also have public take, will be default 10. So this will be the default size for our page. We skip 0. Okay. And we need also to add our list of fatal filter criteria filters like that, and make an instance of a new array. So we have finished that. Now we need to go back to the query parser. So in here now we return query parameters that we need. Okay, and we need to make new instance. Okay, return it like this. Let's make like this so we understand better. So now, what do we have also? We have our parts of query. Like that. So we will just call query parts. So now we iterate over them. Okay. So, as you remember, first we have two options. So we have skip take and other filters. So we will say if part starts with skip equal. What do we do? Like this. Just to try parse. So it's not like that. We need to split it. Split it on equal. That I get the first value. Okay. We will just use int parse actually. Okay, so int parse will throw an error. So we will have to make some try blocks like that. Here, throw new print the exception. We have new error details. Okay. What is it called? this error actually. No, it's actually in print me exception. I get code message and the details. So we just send here the code. Parse error. Message. Parse error. Also field parse error. Like this code, this will be the stats code. Think start dot bed request. Okay, make it in like that. Okay, this will stay like this for now. So we have this for skip. Okay, now we need for take like this, or or is it? So in here we have our filters. So as you remember, we have made space between some filters like products equal to 2, 3. We'll have filter parts is equal query part dot split like this. So let's specify some fade, some length is equal to 3. So we have some protection. Okay. We have our property filter parts of 0. We have our operator type. We have our value. Okay. And we added but filters, add new filter criteria, property, operator value, like this. So that's fine. Try. We'll actually return this here. This will throw. That's okay. Let's specify some controller. For example, in here, like a guest type controller. We have HTTP GET here from query quest query. we actually need first to specify the type. String request query. Okay, what now? So we now need to parse the data. How do we parse data? We use the class that we just made. Query parse. Okay, query parser dot parse. In here we specify our request query like that. In here you see we use Mediator. So now we have this query. We need to use this query parameters. So we have prop query parameters. Query. Like that. We will make constructor that will take this like this. So now in here that's okay. So now where are we next? We go next to the handle method. If you remember how Mediator works. So we need to go to application layer, services, catalog, guest type, queries. In here we have our handle method. In here we have get apps, await repository dot. Here get all filters async. In here query. Okay, we need also this here, our query parameters. Like that. Of course, we have item task like that. Item like this. We do not need this. Okay. So now what's left is for us to handle this method. We here return a variable. That's okay. We get the type. We have this access to the query. That's okay. So this extension method, and here our filters. As you remember, we go like iCollection, and what was it? Filter criteria. So we also need to change the repository. So what do we return here? So we need to apply our filter. So we go return, await. We will see in the future, but for now, let us stay like this. Okay. First, we actually need query. Like that. To build the query. And now we go query is equal to query dot apply filter. Here's our papa parsed. And also, as you remember, we need also to do skip and take. Skip. Like this. Space. If like this, we return query. We return query. If not, we need to iterate for each filter criteria like that. We need to get property name, operator, like that. So next, we need to get the property info for our filter. So we'll go right like this. Info equal type of t get property name. As you can see, you can add some binding flags like ignore case. So this ignore case will ignore the case. Will it be uppercase, lowercase? And what also do we need? We need like this or like that. So public, that we only search for public properties, and instance that we do not include static properties. So now we need to check if actually there is property info. Property info is null. Throw new like that. Argument exception. The argument has not been found. So now we need to convert object value. It's not that. Dot change stuff like this. So what does this do? It converts our type so that our filter value will be the type of our property. Okay. So we need to build actually lambda expression. How we do that? First we need the parameter. That's like in any where clause. For example, this x is parameter. As you can see, it already sees. So we have parameter expression. So we get this parameter of type t. And on that parameter we can access some values, like x dot name, like this. Okay, next we need to get the property. X equal to expression dot property. So we get the specific property. This means like x dot name, like that. We get that property with this property info and this parameter expression. Okay. Now we need to get the value of our filter value. Expression. But we actually don't need this because we already converted this value. Okay. So we will get this value. And now we need to build our expression tree. For that, we'll create new method, private expression build filter expression, like this. We have property, we have value, and we have operator type. Like this. So we need to switch return operator type. We will make it like this to lower. So it is always lower. And we go switch. What do we do here now? If we have equal, what do we return? Expression not equal property value. That's it. Not equal let's do this also. Less than. Would generate. Less than. Greater than. We could also do, I don't know, contains equal to expression dot call. This can call a specific method. Property. What method do we call? We'll call contains method. So this actually calls or contains method inside .NET Entity Framework. We get in here null and value. That's it. For now, that will be fine. In future, we can add here all kinds of things. Operator type not supported. That's it. So we will use this to build our expression tree, our expression body. We'll go now. Body is equal to build filter expression. What do we pass? Property then value that's constant, and operator type. Okay. Operator type we have here. It's actually filter operator. And we actually built our body. Next, we need to build our lambda expression. Expression lambda function t bool body parameter expression, like that. We will actually change this to just parameter so we understand better. Okay. So we now build this with the use of parameter and the body. Body is the actual function, and we have now successfully built something like this, for example, or more than something that we input. Okay, but we have some issue here with this contains. So this contains will work only for one value. If we write something like mode contains one, but what if we want to see maybe if some number group contains 1, 2, 3, if it's inside array or something like that. How do we do that? So we will also need to build contains expression. How will we do that? Build contains expression. Okay, we get the same expression property, its object, filter value, and also we need parameter expression. Our parameter. Okay. If this can only work is filter value is string value. Okay. I accidentally. So we need to get the values. We will actually create an array like that. And we will select each element, get the value, and convert it. Not value that converted. Convert dot change type. So we get the value and property dot type, and we return list. So we get a list of values with the same type. That's the property that we are checking onto. So next we get contains expression equal to values dot select, and now we will for every value we will make expression. We will call property contains in here expression dot constant value, like that. So we do exactly the same as in here. We create the body, the lambda, just for every value inside our list. Okay. And also what we need to do, so we need to compare these. So we will do aggregate. So what does this aggregate do? Or so actually our or else needs two parameters. So we will do this a little bit different. To list. Okay. We have expressions. We now need to create one expression. Contains expression is equal expressions dot aggregate now. Now we use aggregate. So what does it do here? It uses two functions, or like this. Oh, I see. We need to in here, in actually to cast it to expression like this. And now this will work. Convert it to method group. This will now work. Can I just go like this now? Yes, it works actually. We just needed to convert it to cast the expression. And now it works. So we return the contains expression. And in here we will show new error. It's not that the contains operator can only be used with strings. Like that. And now in here we need to build that expression. So we need property value parameter. We actually do not have a parameter in here, so we need to get it. Like that. Okay. So this works now. Let's add some comments in here. Like builds contains contains expression for string values in this format. Like that. You can type these XML comments with these three lines. Fields, filter, expression, comparators, based on filter type. And in here, applies filters and applies filters. Let's go just like that. So we have the repository pattern, and we return this. Now we need to go back here, guest type handler. What do we return here? Guest type. Okay, we need to change this. So in here, what do we need? We need to have a new return type. So as you could see in the repository, we get query to list. So we will make some new class, filter, no, what could response model, something like that. In here, you can say maybe something like page size, or actually not. Count, public, what do we need more? Actually, we will put it first. List, type D, data. Put it first and in here. Add our type. Okay. We will add page number. We will need that for pagination on the front. Page number. Int page size. Maybe total count. Not count. And maybe be total pages. Like that. We'll create this dynamically. But ceiling total count. Page size. Like that. Will this. Done. Okay. We do not need actually get set in here. Or actually the first one's double, so it's fine. Now we need in here to change this query a little bit. So in here we need to get the data actually. Data, okay, and get the total count. async. I can get something like this. And return data total count. And here task, client number. Well, we will let maybe here public class repository response type T prop type T data int total count buys it. Also type T return response. I will make it here constructor, so it's easier for me to do that. Data total count like this, and I will change this inside my repository. In here. Okay. In here, what can we say? Repository response. Okay, so we get here repository response. And now what? Now we need to return the response. We can go first build it. Response, it's equal to new. I can maybe say paged like this. Paged response model of type guest type like this. And let's also in here generate constructor. So what do we need? It's data page number, page size, total count. So it's actually response dot data dot page number. We need in here page number. What's that? It's our this request. We get it from here. So request.query parameters dot skip divided by query parameters dot take +1. That's actually it. Okay. That's actually our page number. Page size is query parameters dot take. Next we have total count. That's actually a total count. I numberable to list. Let's just specify listed here. Okay. And we return okay response. Just response. In here, let's see what do we return inside controller. What the success is return result.value. We will not do that. We'll just change it to results.okay. But okay, now returns response. In here, we get the response. Will not be that. It will be paged response model of guest type. Okay. Paged guest type. In here, we return that. Okay. To get guest types. So let's try it out. We have forgot the main thing that's to apply to lambda. Not that very fair like that. And one more thing. So we have fixed in here to use this query string like this, but we also forgot one thing. That's your decoded HTTP utility. So we need to decode code like that, and we need to remove the first element. That's that question mark on the start of the query string. And now let's try. Okay. So I have done some query and let's see if this works. It has successfully passed. Actually, I did not change. Need to restart the application. Now we need to do it again. Actually failed. Okay. Let's see in here what do we get and let's start again. Okay, we remove query parts. It's not decoded correctly. I see we have used query string. We have not used this. So that was a mistake. Okay, as you can see, query parts code equal that. Let's see, debugging. Go skip and take. These strings code equal guess type 1. That's okay. Push the value. Return parameters. Let's see the response. It's okay. So as you can see, we have data ID 1, ID 5, guess type 1, guess type 1. That's okay. As we have specified here. Here, page number 1. Okay, page size. That's the default page size. Total count 2. Total pages 1. Equal maybe contains 1. Let's see. Work. It does not. Let's see. Because let's see this. Okay. We have some error here. Maybe. Let's see. Let's go to message. Count async we will actually do in here. It's better. Count all the items. Apply filter. Just let me see here. Okay. Let's see now. Query is here. Data's here, filters, contains, cool. Okay. Property of string, value, filter value guess, code, guess. So we have some error. Okay. So error here. Send one more request. It did not pass. Guess. String value. I see now. Okay. We should actually pass to here. Let's not try this. This filter value. This object of the key value. Okay. So it will in here then. Check if it's string value. Stay. What I was sending an expression and it's never string value. So that's why it could have guess. Yes, I'm right. No, it's string values count one. Okay. Expression x.code contains yes. That's okay. That's okay. Okay. Works. Total count with 9. Okay, that's great. It works now. It works. Okay. Actually, we had some errors, but it's fine. It's good as you could see how we could handle these errors, how you could just add some breakpoints, go to the next ones, see what could go wrong. Most of the time, some errors are like basic ones, or you do not see like other there that I use, not the coded URI instead of the code and things like that. So that will be it for this video, guys. Hopefully you enjoyed it, and please leave a like and subscribe, and see you guys in the next video. Bye.